Okay, so I put in the numbers here. As x approaches 4 from the left-hand side, you notice what number do these get closer and closer to? They get closer and closer to negative infinity. And what number do these get closer as you approach 4 from the right-hand side? Well, they get closer and closer to positive infinity. So what that says is, by definition, the heights approach positive and negative infinity as we approach from left or right. That tells us we have a vertical asymptote. Vertical asymptotes, these like imaginary lines that we approach. Okay? And as we approach it from the left, we go to negative infinity. And as we approach it from the right, we go to positive infinity. Okay? So this is the vertical asymptote component. Now, we need to talk about the horizontal asymptote component. Okay? Let's do that now. Okay, so for the horizontal component, now we're looking at what happens as x goes to infinity. Well, as x goes to infinity, x is getting larger and larger and larger. Think about, if you put in 10 here, right, 10 squared minus 5 times 10 plus 4, that's 100 minus 50, 50, 54. 3 divided by 54 is a fraction small. But if I put in 1,000, 1,000 squared minus 5,000 plus 4, it's even a smaller fraction. And if I put in a million squared minus 5 million plus 4, it's even a smaller fraction. So this number, 3 divided by a larger and larger and larger number, is a very small number. So this goes to 0. And if we put in, as x gets to negative infinity, put in like negative a million, minus 5 times a negative million plus 4, it's 3 divided by a large negative number. 3 divided by a large negative number is still going to 0. So what we need to know is that we have 1 over a big number. That equals a small number, right? And we need to know 1 over a small number is equal to a big number. For example, 1 divided by a billion, that's like nothing, right? That's 0. But 1 divided by 0.0000000000001 is a very large number, right? And if you don't believe me, check your calculator. So what that tells us is, as x approaches negative infinity, so my x's are going this way on this graph, I'm approaching a height of 0. And same thing over here, this height is going to approach this x-axis. So this x-axis is now one of those imaginary lines that we approach at in the end behavior of this thing. So what's the quick way to find and graph rational functions? I mean, that's what we want to do, is use this information of understanding, you know, when those zeros of the denominators are and what our numerator and denominator look like of our functions, and be able to graph these things easily and quickly. So let's take a look at this thing. Now, normally, if you tried to plot points in this thing, it would take forever. But what we can do is we can use the rules that we have for an understanding of asymptotes to be able to graph this thing pretty quickly. The first thing is, let's talk about vertical asymptotes, okay? So if I want to talk about vertical asymptotes, what I'm talking about is, when is the denominator 0? When is the denominator 0? This tells us when we have vertical asymptotes. So we set our denominator equal to 0. X squared minus 2x plus 1 equals 0. X minus 1 times x minus 1 equals 0. That happens when x minus 1 equals 0, or x equals 1. So if I'm graphing this thing, right now I know right away at x equals 1, I have a vertical asymptote. Okay? That means my graph is going to approach it like this, okay? Or it's going to approach it this way. Never touch it, never go through it. Or it's going to go this way or this way, okay? So it's one of those 4 cases, and we'll kind of explore that as we go through here, okay? So really this function is now 2x squared minus 4x plus 5 divided by x minus 1 squared, correct? All right, so what happens, and so we're looking at 1, what happens as x approaches 1 from the left, and what happens as x approaches 1 from the right? Well, let's talk about it from the left. It doesn't matter, in the new denominator, it doesn't matter what I approach from, because it's going to get closer and closer and closer to 0 in the denominator, correct? And it's going to be positive no matter what, because I'm squaring it. So if you put in numbers that approach 1 from the left, and you plug them in, x, f of x, you will see that it's going to be one of two things. Number one, it's either going to get really big, or number two, it's going to get really big negatively. So if you want, you can plug in numbers that approach 1 from the left, go 1/2, 0.9, 0.99, 0.999. For me, what I'm going to do is I'm going to skip this. What I'm going to say is this. I want to know what f of x approaches. It's either going to be positive or negative infinity in both of these cases. Well, how do I know which one? Well, I know the denominator is, so I know it's going to be positive or negative infinity. I know the denominator is automatically positive. So what happens when I plug in numbers really close to 1, but not quite equal 1? Is the numerator going to be positive, or is the numerator going to be negative? If the numerator is positive, I'll have positive divided by positive. I know it's going to go to infinity or negative infinity, so if it's positive divided by positive, it would be positive infinity, or if it would be negative divided by positive, it would be negative infinity. So let's take a look. As I approach 1 from the left, give me a number really close to 1, but not equal to 1, and to the left of 1, maybe it's 0.999, okay? Well, you'll also notice that I believe the denominator, let's see, oh yes. So if I take a number, say 0.9999, square it, multiply it by 2, subtract 0.999 times 4 plus 5, is that going to equal a positive number, or is that going to equal a negative number? Well, 5 is big, it's bigger than negative 4 times 0.9999, and then with 0.999 squared plus 2, or times 2, it's going to be positive. So we know this thing goes to positive infinity as x approaches 1 from the left. So my graph is going to approach this thing from the left, okay? It's going to approach positive infinity. And what happens if I approach from the right? As I approach 1 from the right, over here, is it going to go up or is it going to go down? That's my question. Well, give me a number really close to 1, but to the right of 1. Right? We could go 1.5, 1.1, 1.01, 1.001. Your choice. You can plug those numbers in to see what's going on, or you can do it my way. The bottom is automatically positive because I'm squaring it. We know it's got to be positive infinity or negative infinity for this one. Is it going to be positive or is it going to be negative up here? Well, again, if I put 1.001 times 4, it's not going to be as big as 5. So even though that's negative plus 5, it'll be larger. Plus 2 times 1.1, it's going to be positive. So this is going to positive infinity as well. So I know my graph will go this way. So I've got my vertical asymptotes down. My vertical asymptotes I've completely discovered and figured out, and we're dialed on that. Okay. The other piece is the horizontal asymptotes. Well, I'm going to use a trick for this. Okay. So if I have f of x equals 2x squared minus 4x plus 5 divided by x squared plus 2x plus 1. What I can do is I can note that if I multiply top and bottom by the same thing, I'm going to go 1 over x squared, 1 over x squared. I don't change the expression for values that when x is not equal to 0. So I'll get 2 minus 4 over x plus 5 over x squared, distributing, and I'll get 1 plus 2 over x plus 1 over x squared. So this function is equal to this function at values not close to 0, right? Because when I have x equals 0, this doesn't make it, it doesn't make any sense. Well, what happens as x goes to infinity and as x goes to negative infinity? Well, as x goes to infinity, think about large values of x. 4 divided by 1,000,000,000. Is that anything? No, that's roughly 0. 5 divided by 1,000,000,000 squared, that's basically 0. 2 divided by 1,000,000,000, basically 0. 1 divided by 1,000,000,000 squared, that's basically 0. So as x gets large, really this thing equals close to 2 over 1. So as x goes to infinity, okay, f of x goes to 2. And same thing can be said for negative infinity. As x goes to negative infinity, 4 divided by a negative billion, 5 divided by a negative billion squared, 2 divided by a billion, or negative billion, 1 divided by a negative billion. Those are all zeros again. So f of x approaches 2. So that means 2 is a horizontal asymptote. Okay? Now, I know that I have to approach it. So I know I have to approach it this way, and I have to approach it this way. Now, it is possible to touch and come back. Okay? It is possible to touch, a horizontal asymptote and then approach it from the other side. It is never possible to touch a vertical asymptote. If you have a vertical asymptote, you'll never intersect it. But if you have a horizontal asymptote, it is possible that you touch it, say, and then approach it from the other side. So we have to kind of figure that out. And the way that we do that is we're going to ask ourselves, does this function ever have height 2? Does this function ever have height 2? That is, does 2x squared minus 4x plus 5 divided by x squared minus 2x plus 1 ever equal 2? So that's the question. Does that function ever have height 2? Well, if I multiply both sides by this, I'll have 2x squared minus 4x plus 5 equals 2x squared minus 4x plus 2. Subtract 2x from squared root of both sides, add 4x to both sides, and I get 5 equals 2. Does 5 equal 2? No. Therefore, this function never touches this line, never has height 2, so it will never cross it, and it will just approach it. Okay? Good. So we graph this function. It's kind of a mamma jamma. What I want to take away from this is the following. Horizontal asymptotes. All you have to look at is the ratio of the leading coefficients, okay, if they're balanced. Maybe I need to go, I'll go through that right now. Okay, so this looks like a very complicated definition. I'm going to make this so simple, okay? Finding asymptote of rational functions. If you have some rational function, we have a polynomial divided by a polynomial. The vertical asymptotes happen at x equals a, where a is the 0 of the denominator, okay? That is, factor the denominator. I factor the denominator, 2x, x, and let's go plus 2 minus 1. It happens when you have the zeros of the denominator. Those happen at x equals 1/2 and negative 2. So these are my vertical asymptotes. So if I'm graphing this thing, my vertical asymptotes happen at, right, negative 2 and 1/2. Super easy, right? Super easy. Okay, got my vertical asymptotes. Horizontal asymptotes. They're talking about the degree of n and m and all this other stuff. If n is less than m, all I want you to do is do this. Is this top heavy, bottom heavy, or balanced right here? Is this top heavy, bottom heavy, or balanced in terms of degree? The degree is 2. Degree is 2. The leading term has degree. This is a degree 2 polynomial, degree 2 polynomial. Is that top heavy, bottom heavy, or balanced? So I say it's balanced because 2 equals 2. It's this case here. It's balanced, right? This is the balanced case. So if it's balanced, we just take the ratio of, and that should be b to the m, sorry about that. We take the ratio of the leading coefficients. Since this is balanced, degree 2, we take the ratio of 3 to 2. So y equals 3/2 is my horizontal asymptote. So this is 1, that's 2. My horizontal asymptote will be right there. Okay? Super easy. Okay? Next problem. If I factor this thing, it helps me find my vertical asymptotes. X plus 2, x minus 2, 2x. Okay? So let's find, when does x plus 2 or x minus 2 equal 0? Those are my vertical asymptotes. X equals 2 and negative 2. Good. Found my vertical asymptotes. Good. How do I find my horizontal asymptotes? I look for it. Is it balanced, top heavy, or bottom heavy? Well, my degree on the top is 1. My degree on the bottom is 2. Is that top heavy, bottom heavy, or balanced? So this is top heavy. This is bottom heavy. Well, I say this is bottom heavy, right? Degree 2 is bigger than degree 1. So since it's bottom heavy, then R has a horizontal asymptote to y equals 0. That is, the x-axis is my horizontal asymptote. Okay? So it is super easy to find asymptotes if you think about it. Bottom heavy, top heavy, and balanced. If they're balanced, you look at the ratio. If they're bottom heavy, we know it's y equals 0. Okay? So that line right there. And if it's top heavy, there is no horizontal asymptote.